Hello, grade 11. Yeah, I'm sorry I can't be with you. Hospital is not very fun. I'd much rather be with you, but here we go. You get me from afar. Right, today we're working on trig identities. So this is quite different from the stuff that we've done before. You can't look up answers for this because they give you the answers. They're asking you really to solve identities, which means they say one thing equals another. Show me how you get there. So the first thing we're going to do is remind ourselves of the two identities we know. Tan theta is sine theta over cosine theta. And obviously the reverse is true as well. If you see this, you can turn it into this. And then we have this really important identity that we're going to use a lot. And I want you to remember the rearrangement of this. So you can also say that sine squared x is the same thing as 1 minus cosine, why do I keep trying to write theta, x, and that cosine squared x is also the same as 1 minus sine squared x. So these are really important. Obviously, so is this, but this will come up a little more. So I'm just going to show you how to do a couple of these and talk you through why they work. So what you're going to be, first of all, let me just write one up. All right, so if I give you something like this, 4 cosine squared x minus 3 sine squared x, I'm going to ask you to put this in terms of cosine x. So what that means is I'm not allowed to have sine here. I must only have cosine. So what I need to do is think about the identities that I just had. Say, right, how can I make this into a cosine? Hopefully you can think about the rearrangement I just did. We know that cosine squared x is 1 minus sine squared x, and I'm going to show you how to use this. So the first thing I'm going to do here is just slightly rewrite this so that I can use the identity that I have. If I take out, whoops, why did I write equals? I meant to write minus. So if I take out 3, this is now, right, sine squared x. But I know that this, or actually, well, I've written this the wrong way around, haven't I? So what I know now is that sine squared x is actually 1 cosine squared. Ow! Sorry, just hurt my hand. Okay, I have an IV in my hand, which constantly hurts me. So if I say ow, it's because I've moved my hand the wrong way. So if sine squared x is, ow, 1 minus cosine squared x, I am going to substitute that in here. So now I have 4 cosine squared x minus 3, and this is now 1 minus cosine squared x. So now I can distribute this. So I've got 4 cosine squared x minus 3 plus 3 cosine squared x, right? These two negatives cancel out. Now I've got like terms. 4 cosine squared x plus 3 cosine squared x is 7 cosine squared x, and then I still have a minus 3 right here. So another way you can think about that, if it helps you, is this is like 4m squared minus 3 plus 3m squared, right? Like you can just substitute this as any letter you like. So then I get 7m squared minus 3, and then m squared is cosine squared x. If that helps you, great. If not, just use this. These are like terms. So this is rewriting this in terms of cosine x. So when they ask you to write things in terms of whatever, any trig ratio that is not whatever they said, you need to figure out how to turn it into that. So we know how to turn sine into cosine. It's this identity here. All right, I'm going to save this. Let's do another one. So the next one I'm going to do is again ask you to prove an identity. So we have, this time we're going to use fractions. 1 plus sine of x over cosine of x. And I'm going to add that to cosine of x over 1 plus sine x. And I'm now going to give you an answer. I'm going to tell you, and you'll notice I'm going to use 3 lines instead of 2 because this says it's an identity. These two things are equivalent. I'm going to tell you that that is the same thing as 2 over cosine x. Now, you can start from either this side and turn it into this, or you can start with this side and turn it into that. Now, let me tell you the easiest way to do this is to start with the more complicated one, right? It's much easier to reduce things than expand them because expanding them, there's usually more options. So what I'm going to do is think about how do I get this into that? Now, I know the answer is in cosine, so I need to really focus on this bit here and this bit here, right? They need to turn into cosines because obviously that's what goes on here. Now, hopefully you can see the first thing I should be worried about is I've got two fractions that need to go together. How do you add together fractions? Well, they need common denominators. So I'm going to leave the top as it is right now, sine x, and then plus cosine x. So I just really need to make common denominators. So I'm going to multiply these things together, right? Cosine x, don't really need brackets for that, times 1 plus sine x. All right, so what I'm going to do here is think about how I can, oh, that was really dumb of me. Why did I try and do all that in one step? I am on quite a number of drugs right now. Okay, not allowed to do that. Okay, whatever I multiply the top by, I've got to multiply the bottom by. I'm going to really extend this out. So if I multiply this by 1 plus sine x, I have to multiply the top by 1 plus sine x. So that's just itself. So let's just square it, right? That times that is just itself squared. And look at that. This is the same thing. So now I have cosine squared x, which means I really didn't need that. All right, this is what happens when you get a class done by a teacher who's taking a fair bit of medication. Okay, now you need to look at this and think about what you're going to do. What identities do you have? Well, first of all, let's get rid of our brackets. We need to start combining stuff. This is a perfect square, right? So let's just move this up a bit so we have some more room. So this is just think about, remember, this is two brackets and we have to FOIL it. You can't just square first and last terms. So this is 1 plus 2 sine x plus sine squared x. Gosh, so think about this, right? This is 1 sine x times 1, plus sine x, and then I do FOIL, right? So this is 1 sine x, sine x, sine x squared, right? That's what's going on here. Plus cosine squared x, and then I'm just going to distribute this. Actually, no, I'm not going to because I'm going to end up with something else in a minute. You could, if you did distribute it, it wouldn't be wrong. It would just mean you'd have to put it back in brackets later. So, all right, now I'm going to give you a second to look at this. What do you notice? That is an identity, is it not? So the identity that we know is that that equals 1, right? How great. So this is going to be 1 plus 2 sine x plus 1. That makes our lives a lot easier. Cosine x, 1 plus sine x. All right, fantastic. So this makes our lives a lot easier so far. What I'm now going to do is, the great thing about these questions is you know what the answer is. So I've got to somehow make it look like this. So the top needs to become a 2. So I need to do something here. And the bottom needs to become a cosine x. And the great thing is, I know I only need this, so I have to get rid of this somehow. So what I'm going to do is think about how I rearrange this. So first of all, let's put our ones together. So I've got 2 plus 2 sine x over cosine x, 1 plus sine x. Well, my writing's getting worse. And what I'm going to do is I'm going to factor out 2 because that's what I needed as my answer, right? Remember, I'm going to end up with this. So I need to get rid of all of these things. I need a 2 left on the top. So if I factor out my 2, I get that. How good is that? And look, these brackets match now. Hey, look at that. So, whoops, not sine, sorry, cosine x. That is what we needed to end up with. So we've done this question. This time we're doing another identity. Again, we've got this and we're asked to make it into this. Now, like I said last time, it doesn't matter which side you start with, you just have to get to the other one. Personally, I think this time it's easier to start with this side. I know I did the other side last time, but This looks easier to me because it's all in terms of sign. It's going to be easier for me to make this turn into sign than to somehow get that to turn into this mess. So the first thing I'm going to do is just ignore that and know that that's the answer. Now, I've got a squared here, so I need to open up these brackets, but first I'm going to combine these. That's going to make my life a lot easier. Now we're going to use this identity to get these together, right? So first of all, I'm going to say that tan of x, I know, is sine x over cosine x, right? And look at that. Now I've got matching denominators. 1 over cosine x. So just rearranging that allows me to, put these together. So now I have sine x plus 1 over cosine x. All right, that does not look like a plus. And this is all squared. Now this looks like something I can square. This is going to make my life a little bit easier. Remember, when you square fractions, you're just squaring top and bottom, right? So because this is not two terms, I know that it looks like there's two terms on the top here, but what I'm going to do is say that the top here is sine x plus 1, that is squared, and then this turns into cosine squared x, right? Just square top and bottom, and that's what it looks like. Now, the next thing I'm going to do is think about the fact that they need to both be in terms of sign, right? Remember, what we're aiming for is just in terms of sign. So the top part looks pretty good for now. The bottom part does not. But this is where our identity is going to come in handy. Remember, sine squared x plus cosine squared x is 1. So that means cosine squared x is 1 minus sine squared x. So I'm going to substitute that. So I still have sine x plus 1 all squared, but on the bottom, now I have 1 minus sine squared x. Now, this is the bit that people will often miss. Have a look at this bottom bit. Can you see a pattern? Is there something we know about this that's going to help us? I'm going to give you a second to think. Starts with D. This is a DOPS pattern, something squared minus something squared. So if I rewrite the top, still got this. The bottom now looks like 1 minus sine x and 1 plus sine x, right? So this is an expanded version of DOPS, or sorry, a factorized version of DOPS. And this, another way to write this is that there's two of these, right? Anything squared means there are two brackets. And now I've got matching brackets. Doesn't matter which way around they are, they're just adding. So now I have 1 plus sine x, or sine x plus 1, doesn't make a difference. 1 minus sine x. And that was what we were looking for. Yay! All right, so this is our final answer. All right, so I'm going to ask you to do identities today. I know this is really hard. This is a terrible lesson for me not to be there for because it requires so much knowledge that you can't just find the right answer. It's actually about the process and how you get there in the first place. But as long as you figure out, like, this identity is so important, right? This one just here. If you can constantly think about how to use this, rearrange it, so when you've got something like that, always think about ending with the simplest term, right? So last time we ended with the simplest thing. Start with the complicated one. Try and say, right, where am I going? What identities are going to help me? Try and break it down a bit at a time. When you've got multiple fractions, put them together first. Try and condense things as much as you can. Feel free to email me. I'm so sorry I'm not there. I hope this goes well. Yeah, good luck.